Hyster begins first ever real-world pilot of hydrogen fuel cell powered container handler at the Port of Los Angeles. And I'll run through the list of nuclear power plants in the US that are looking to produce hydrogen. All this on today's Hydrogen Podcast. So the big questions in the energy industry today are: how is hydrogen the primary driving force behind the evolution of energy? Where is capital being deployed for hydrogen projects globally? And where are the best investment opportunities for early adopters who recognize the importance of hydrogen? I will address the critical issues and give you the information you need to deploy capital. Those are the questions that will unlock the potential of hydrogen, and this podcast will give you the answers. My name is Paul Rodden, and welcome to the Hydrogen Podcast. In a press release on October 11th, Hyster Company announces testing of a top-pick container handler powered by hydrogen fuel cells at Phoenix Marine Services in the Port of Los Angeles. Building on the industry standard Hyster H1050-1150XDCH top-pick container handler design, the truck is powered by two 45-kilowatt hydrogen fuel cells from Nuvera, a wholly owned subsidiary of Hyster parent company, Hyster Yale Group. A California Climate Investments grant awarded by the California Air Resources Board in 2018 helped support the development of the HFC-powered container handler. The HFC-powered top pick is designed to provide the zero emissions benefits of a battery electric option with enough capacity to keep operators moving and avoid the need to stop in the middle of a shift to refuel or recharge. Refueling the top pick with hydrogen fuel is expected to take approximately 15 minutes, with the intention to provide 8 to 10 hours of continuous runtime, all while producing no harmful emissions, only water and heat. The hydrogen fuel cell works in tandem with an onboard lithium-ion battery to either power the equipment directly or charge the onboard battery. The top pick is also equipped with a patented Hyster energy recovery system for electric container handlers that recovers and stores energy from lowering loads and braking. The Phoenix Marine Services Container Terminal, which was acquired in 2021 by the CMA-CGM Group, a global player in sea, land, air, and logistics solutions, uses compressed hydrogen delivered on-site to fuel the top pick. In a quote from CEO Steve Trombley of FMS, "We are excited to participate in this pilot and implement another sustainable solution designed to help meet Clean Air Action Plan 2030 objectives. Exploring the use of hydrogen as a zero-emission fuel source is important for the entire transportation industry and is a perfect complement to the other alternative energy research and development projects our parent company, CMA-CGM Group, is spearheading to protect the planet and reach net zero carbon by 2050. Now, to electrify higher capacity equipment for port terminals, Hyster draws on extensive experience in electric truck design with the company's line of smaller, lighter capacity powered industrial trucks used in both indoor and outdoor settings. The company has recently launched lithium-ion powered forklifts with load capacities up to 36,000 pounds, and previously announced a pilot of a fuel cell powered reach stacker at the Port of Valencia, a fuel cell-powered empty container handler at a terminal in Hamburg, Germany, and a joint partnership to develop electric and hydrogen-powered terminal tractors. In a quote from Jan Willem Vanderband, Director Global Market Development, Big Trucks at Hyster, "Our mission is to provide the innovative technologies our customers need to help meet their goals for emissions reduction and performance. For some operations, lithium-ion power might be the answer, but for others, hydrogen is the right choice. The answer depends on so many factors like duty cycle, utility grid capacity, and fuel availability. Our customers deserve choices that allow them to build the right solution based on their needs, not shoehorning in on a single technology into their operations." This project is part of California Climate Investments, a statewide initiative that puts billions of cap-and-trade dollars to work reducing greenhouse gas emissions, strengthening the economy, improving public health and the environment, and providing meaningful benefits to the most disadvantaged communities, low-income communities, and low-income households. Okay, so this is a really exciting press release. Now, before I jump into the analysis, my producer is making me mention that Hyster's marketing team has inquired about exclusive sponsorship opportunities with the podcast, but that is not going to have any bearing on the advice or analysis that I give about the companies that I discuss. Now, that being said, I do love this news because this is broadening the real-world examples about where hydrogen is being used in a day-to-day basis. So often we talk here on the show, and the news in general is discussing projects that are 2, 3, 4, 10 years down the road. This announcement is showcasing something that's in testing right now. Okay, so this may seem like a normal press release about a hydrogen fuel cell powered container handler, but it highlights something much bigger on the near horizon, and that is hydrogen hub development at key ports around the world. We're beginning to see this take place in the Gulf Coast ports, and now this announcement at the Port of Los Angeles. This tells me that very soon we will see global distribution of this kind of equipment at, say, the Port of Vancouver and Montreal. We'll see it in the Netherlands, we'll see it in Japan and South Korea, and in Australia at maybe the Port of Fremantle. This announcement showcases that we are on the precipice of something very big, as this shows a need for hydrogen hubs at every port. And with hubs at every port, that opens the door for heavy freight FCEV delivery, fuel cell rail takeaway, and hydrogen and ammonia driven shipping. Now, it's no secret that the maritime sector is looking to fuel cells to help solve their decarbonization efforts, and these hubs are going to make that a reality. Next, in an article from Kevin Clark in Power Engineering, these 4 U.S. nuclear plants will start producing clean hydrogen. The U.S. Department of Energy is partnering with utilities on 4 hydrogen demonstration projects at U.S. nuclear power plants. Hydrogen would be produced at the nuclear plants through high or low temperature electrolysis, a process of splitting water into pure hydrogen and oxygen. High temperature electrolyzers use both heat and electricity to split water and are more efficient. Many believe nuclear is a tool to produce clean hydrogen, which is seen as an important path to drive decarbonization, including in hard-to-abate sectors. In power generation, hydrogen is one of the leading options for storing renewable energy and can be used in gas turbines to increase power system flexibility. The 4 power plants are 9 Mile Point Nuclear Power Station in Oswego, New York. The DOE is supporting the construction and installation of a low-temperature electrolysis system at the 9 Mile Point Station in Oswego, New York. 9 Mile Point would be the first nuclear-powered clean hydrogen production facility in the U.S. and would also use the hydrogen to help cool the plant. Constellation plans to begin producing hydrogen there before the end of this year. The utility also partnered with Hyster on a separate project to power a fuel cell at the facility and will start providing additional power to the grid in 2025. The next plant on the list is the Davis-Besse Nuclear Power Station in Oak Harbor, Ohio. Energy Harbor is working to demonstrate a low-temperature electrolysis system at the Davis-Besse Nuclear Power Station. The single-unit reactor is expected to produce clean hydrogen by 2023. Energy Harbor is part of a larger group called the Great Lakes Clean Hydrogen Coalition. The GLCH aims to develop a Midwestern regional hydrogen hub and is applying for DOE funding. Hydrogen produced at the Davis-Besse could support local manufacturing and transportation services, including fuel for a local bus fleet. The third project on the list is the Prairie Island Nuclear Generating Plant in Red Wing, Minnesota. Xcel Energy is working on a demonstration plant coupling Bloom Energy's high-temperature electrolysis with the Prairie Island Nuclear Plant in Red Wing, Minnesota. Engineering for the Xcel Bloom 240 kilowatt demonstration is currently underway, with construction expected to begin in late 2023 and power on expected in early 2024. The last plant is the Palo Verde Generating Station in Tonopah, Arizona. Finally, DOE is negotiating an award with Arizona Public Service and PNW Hydrogen to demonstrate another low-temperature electrolysis system at the Palo Verde Generating Station in Tonopah, Arizona. The hydrogen would be used to produce electricity during times of high demand or to make chemicals and other fuels. The project could start producing hydrogen in 2024. Now, according to the DOE, a single 1,000 megawatt nuclear reactor could produce more than 150,000 metric tons of hydrogen each year. 10 nuclear reactors could provide about 1.5 million metric tons annually, or 15% of current hydrogen produced in the United States, this according to the DOE. Okay, so this is more news that I'm really excited to hear. Now, I've talked a few times about the Prairie Island Nuclear Generating Plant partnering with Bloom Energy and Xcel Energy. And it could be the reason it's generating the most press is that it's using the high-temperature electrolysis unit from Bloom Energy. But regardless of that, it seems like a no-brainer to me to utilize the excess heat and excess electricity from nuclear stations to generate hydrogen for mobile applications, ammonia, and hard-to-abate sectors. So when it comes down to the best methods of generating electrolyzed hydrogen, to me, nuclear is the only answer right now. All right, that's it for me, everyone. If you have a second, I would really appreciate it if you could leave a good review on whatever platform it is that you listen to. Apple Podcasts, Spotify, Google, YouTube, whatever it is. That would be a tremendous help to the show. And as always, if you ever have any feedback, you're welcome to email me directly at info@thehydrogenpodcast.com. And as always, take care, stay safe, I'll talk to you later. Hey, this is Paul. I hope you liked this podcast. If you did and want to hear more, I'd appreciate it if you would either subscribe to this channel on YouTube or connect with your favorite platform through my website at www.thehydrogenpodcast.com. Thanks for listening. I very much appreciate it. Have a great day.